SURD is defined as a number written with what? Square root. But what type of number? That's the key word. What type of number? So I'll redefine that. Okay. SURD is the square root of a non-perfect square. In other words, root 4 is not a SURD. Root 9 is not a SURD. Because root 4 is what? Plus or minus 2. Root 9 is plus or minus 3. But root 2, we don't know. You have to check the table. It's a SURD. Root 3 is a SURD. So it's only when the number is a non-perfect square we call it a SURD. And this is just a way of how to deal with such numbers. So the first exercise will show you how to rewrite any number that is given in a proper way. For example, root 54 is not a SURD because 9 is a factor. 9 times 6 is 54. And square root of 9 is 3. So we will not just write root 54, we say 3 root 6. Isn't it? Root 27 again is 9 times 3. Therefore, root 27 is 3 root 3. Root 8 is not a SURD because 8 is 4 times 2. And square root of 4 is 2. So root 8 is what? 2 root 2. So the first step you take in anything you want to do in SURD is reduce it so that you don't have a big number that you deal with. In other words, that rule under indices, work with prime factors. Work with improper fraction. And work, if you like, with fractional rules. In this case, the fraction is fixed as half. So, what do we do? How do we deal with this? You may be asked again to simplify. And in simplification, I've told you, first step, rewrite so that you have a number root, a number that is not a perfect square. So when they say simplify, it's just collecting like terms, as you do in any algebra. You're collecting like terms. So if I have root 2 plus 5 root 2, I use the coefficient of root 2 to add them up. That's 1 plus 5. So I get 6 root 2. Provided the sorts are the same, I can collect them. You can collect root 3's together. You can collect root 2's together. And that's simplification. Where multiplication is involved, you are to remember the third law of indices that says a power raised to another power will be multiplied. Isn't it? So if I have root 2 times root 2, it means 2 raised per half times 2 raised per half. If I add half to half, what do I get? 1. So when a SURD is multiplied by itself, or squared, so to speak, you just get the number. The square root disappears. Not that it disappears, you just square it off. And so we use that particular fact when it comes to multiplication to make life easier for us. Then in division, if you cast your mind back to when we were doing decimal, the rule then was to divide decimal, rationalize to get the denominator to be a whole number. because it is easier to divide when you have a whole number as your denominator. 0.6 divided by 2 will give you 0.3. 0.06 divided by 2 will give 0.03. But the moment you say 0.6 over 0.000 something, you have a problem. Therefore, you must rationalize first by moving places of decimal that will make the denominator to be a whole number, and move the same places of decimal. This principle is applied in SURDS. When you have a number over a SURD, the SURD is usually point something. Root 2 is 1.141 something. Therefore, you don't leave the denominator as a SURD. You rationalize. It's what you did in decimal you are doing here. And I have just told you that a SURD multiplied by itself will remove the square root sign. So that is the concept we use when we rationalize. So if I have 3 over root 2, what do I use to rationalize? Root 2. I multiply the numerator by root 2. I multiply the denominator by root 2. So I get 3 times root 2, which is 3 root 2 as the numerator. The denominator will be root 2 times root 2, which is 2. So instead of writing 3 over root 2, it is better to write it as 3 root 2 over root 2. That is rationalization. And then the last bit is conjugates. Conjugates. If you remember when we're doing quadratic factorization in JS syllabus, you know that you have what is called difference of two squares. The difference of two squares is the product of the sum and their difference. Therefore, if I have a squared minus b squared, I will write it as what? A plus b into a minus b. This is the principle you add. When you have a SURD that is an expression like root a plus root b as a denominator, you have to look for the conjugate. The conjugate is that one that when you multiply by it, it gives you difference of two squares. So the conjugate of root a plus root b is, did you get it? Root a minus root b. The conjugate of root 2 minus root 3 is root 2 minus root 3. So if you have a SURD where the denominator is an expression, you multiply the numerator by the denominator by the conjugate of the denominator. That way, if you multiply root 2 plus root 3 in bracket by root 2 minus root 3 in bracket, you get what? 2 minus 3. Because the square root will disappear. The square of 1 minus the square of the second one. Those are the points you need when you solve exercises. There is nothing in that, it's just grammar. Okay? Good luck. SURD is the square root of a non-perfect square. So first question, simplify root 24. Obviously, this has a perfect square that is a factor. So break 24 into 2, a perfect square and a non-perfect square. What would that give you? 4 times 6. So this is equal to square root of 4 times 6. And since you can find square root of 4, it will be 2 root 6. That is the simplest form. That's all. You must write your SURD properly, otherwise it won't sound right. Then the next one, root 128, which means square root of what perfect square is a factor of 128? 64, isn't it? 64 times 2. Therefore, this will be what? 8 root 2. The square root of 64 is 8, then the root will be on 2. Then rationalization, which means to get the denominator to be a whole number. That's what we did here, just like you did in decimal. Get the denominator to be a whole number. So if you have 28 over root 8, 28 over root 8, The first thing to notice, root 8 is not a proper sort. So you change root 8 to what? That's 4 times 2, 2 root 2. So this is 28 over 2 root 2. So straight away, these two can cancel this to get 14. What you need to rationalize is the root 2. And we are using the fact that half plus half is 1. So root 2 raised to power 2 will give you 2. So what we do is multiply the numerator by root 2, multiply the denominator by root 2. And a number divided by itself is just 1. It's just like saying multiply by 10 raised to this power by 10 raised to the same power. But what we now have is 14 root 2 over root 2 times root 2 is 2. And now you can even say 2 here 1, 2 here 7. So the final answer is 7 root 2. That's just making it simpler. 3 root 8 times 5 root 3 times root 7 all over root 42 times 2 root 3 times root 15. The key word here, or the basic concept here, work with prime factors. Work with prime factors. Break your number as smaller, to the smallest factors you can get. So here 8 is 4 times 2. So this becomes 3 times 2 root 2 and times 5 root 3 times root 7 all over. Then the root 42 becomes 42 is 2 times 3 times what? 7. So you break root 42 to root 2, root 3, root 7, because it will still be root 42 times 2 root 3, and finally your root 15. Your root 15 is what? Root 3 times root 5. So times root 3 times root 5. And now, once everything is broken into pieces, the rest is just picking them out. So root 3, we cancel root 3. Root 2, we cancel root 2. Isn't it? What else? 2, we cancel 2. 1, 1, 1, and so on. Root 7, we cancel root 7. Root 3 and root 3 will give you 3. So root 3 times root 3 will cancel 3. And then you are just left with 5 and root 5. At this point, I'm tempted to say root 5 in 5 will give me root 5. But some of you may not get that. So I'll take time and rationalize. So I get 5 over root 5. And now multiply by root 5 over root 5. So I get 5 root 5 over 5. So that 5 cancels 5. It's a silly way of doing it. I would have said 5 is root 5 times root 5. Cancel one of the root 5. So the answer is equal to root 5. Work with prime factors. 4 root 27. 4 root 27 minus 2 root 48 minus 3 root 75 minus 3 root 75 plus root 108 plus root 108. Again, it's just rewriting all this. So let's start with root 27. That's 9 times 3. So this will be 4 times 3 root 3. And this 48 is 16 times 3. And 16, square root of 16 is 4. So minus 2 times 4 root 3 minus, this is 25 times 3. And square root of 25 is 5. So minus 3 times 3 root, 5 root 5. 5 root 3 plus, this is 36 times 3. Square root of 36 is 6. So this will be what? 6 root 3. Then you just collect like terms. 4 times 3, 12. Plus 6 minus 2 times 4, 8. 3 times 5, 15. All of root 3. Collect like terms. So this is 18 minus 8 times 5, 8 plus 5, 23. 18 minus 5 root 3. What would that give us? 18 minus 23 is what? Minus 5 root 3. All you are supposed to remember is collect like terms.